Welcome back. It's been a while. You notice that my hair is completely out of control at the moment, as I assume yours is as well. In the first few lessons back this year, we'll just complete a few things that we didn't finish on light. Now, I think the only thing we've not really covered yet is lenses. So in this lesson, we'll look at lens ray diagrams. I want to do something slightly different in this video. I want to use this video to set you some questions. So you can look at the question, pause the video, do the diagram, move on. And then in the second video, I'll give you the answers, my answers, and see how they compare to yours. So I hope that makes sense. Now, first of all, we should answer the question of what is a lens. A lens is a curved piece of glass, like this, as you can see in the diagram above my head. And Cambridge says the only types of lenses we need to look at this year are convex lenses. Sometimes they're called converging lenses. And they're the types of lenses that kind of bulge outwards in that shape, as you can see in the diagram. Convex or converging lenses bring light together to a point. So therefore, in most cases, what you're doing is you're focusing the light and therefore you're producing a real image. A real image being an image that you can put onto a screen. So these are the types of lenses we get in the projector in the classroom, for example, that you can put an image onto a screen. When we draw these diagrams, we're going to draw them to scale. So before you start, please make sure you've got a pencil, a rubber, a ruler, and your notebook, please. What we'll do is in these diagrams, we'll put the object, the object on the left of the lens. And in this case, not in all cases, in this case, you can see the image is on the right. Okay, so let me give you a few instructions about how we produce these diagrams. First of all, just have a quick look at this diagram on the top right. This is a convex lens and it's focusing the light. Now, if the light is coming in horizontally, or these are called parallel rays of light, parallel rays, any parallel ray of light will always be focused to one point, which is called the focal point of the lens. Every lens has a focal point, and the distance between the focal point and the center of the lens is the focal length. Fat convex lenses have short focal lengths, and skinny convex lenses have long focal lengths. Okay. You can see here, here's my image. Here's my object. I keep getting that confused. Here's my object. I've chosen an object that's producing its own rays of light. It's a light bulb. Now, if we take 1 point on that object, I've chosen the very top of the bulb where it's producing light. If we follow 2 rays of light and find out where they join together, we'll find the top of the image. This is the top of the object, and we follow the rays down. This is the top of the image. Now you can see the image is, in this case, further away from the center of the lens than the object. And the magnification of that lens is going to be equal to the image distance divided by the object distance. So we can see from a scale diagram if the image is magnified or diminished compared to the object. Here's the equation. Magnification M equals image distance divided by object distance. There's a more obvious way to calculate magnification. Can you say what it is before I tell you? Yes, well, I hope you said that magnification can also be the image size compared to the object size. In other words, that distance measured with your ruler compared to that distance measured with your ruler. Okay, let's get on to drawing the diagrams then. Okay, when you draw a diagram, a lens diagram, the first thing you draw is a horizontal line across the center of your page. That's called the principal axis. That basically locates the center of your lens and the bottom of the object and the bottom of the image. The second thing you draw is a vertical line which goes through the center of the lens. Now you can draw a lens like this, like I've drawn it here, or you can draw it like I've drawn it badly here. You can draw it as a vertical line with a little cap at the top and a little cap at the bottom. It's up to you, as long as that lens has a straight vertical line down the center drawn with a ruler, not like I've drawn it there, not a wobbly line. And the center of the lens needs to be 90 degrees from the principal axis. Okay, now this is important. When you draw the diagrams, please make sure that all of the refraction is occurring at the center line of the lens. Don't show it refracting when it's hitting that surface. Otherwise you'll get your image in the wrong place. Okay, now the last thing you need to draw on your lens is something called a focal point, which I've mentioned already. On your scale diagram, you can decide how far that focal point is from the lens, or if it's an exam question, they'll probably tell you. In my drawing here, it looks like my focal point is 5 centimeters from the lens. So I've done a focal point 5 centimeters from this side of the lens, and a focal point about 5 centimeters on the other side as well. You draw it on both sides. What you can also do is, if this is 5 centimeters, you can put a 2f, or 2 times the focal length, which will be 10 centimeters on that side and 10 centimeters on that side. You decide how far it is from the lens, but in each diagram that we do today, please keep it the same distance in each diagram. Okay, and then finally, your image, we put the object on the left-hand side in all cases. In some cases, your image, or in most cases perhaps, your image is going to be on the bottom right of your diagram. So make sure you're leaving space bottom right of the diagram, but also the image might appear on the top left, so leave plenty of space up there as well. Okay, all right, I'm going to attempt to draw the first diagram for you, or the first question, and then I've got about another 3 questions that I'd like you to try yourself and see if you can get it to work. Okay, so here's my first question. What can we say about the image if we put the object further away than f, but not as far away as 2f? So in my diagram, if my focal point is 5 centimeters, I'm going to put an object somewhere between 5 centimeters and 10 centimeters on the left of the lens. Okay. In this case, I've not drawn my object as a light bulb, I've drawn it as an arrow. In most cases, we'll use an arrow because an arrow has a definite bottom and a definite top. The arrowhead represents the top. And we'll draw rays of light just leaving the top of that arrow, the top of the object, the top of the arrowhead. Okay. I was going to draw it with my pen, but I've realized it's going to be an extremely wobbly line, so I'm going to click on my little PowerPoint, insert, you get this right? Insert shape, insert line. Okay, and I'll draw 2 lines from the top of the object. Now the first line I'm going to draw, if you shine a ray of light directly through the center of the lens, or directly through a piece of glass, it will just go straight through. So I'm going to attempt to draw a ray of light, you can see that, it goes in a straight line through the center of the lens. And I will, if I can work out to do it, I will put a little arrowhead on that line to show the direction of the ray of light. Okay, now in every ray diagram you draw 1 ray of light going through the center point of lens. Draw it very, very carefully, please. It starts at the top of the object and it goes through the center and then it just carries on. Okay. Now you might have already guessed where the second ray of light is going to go, so I'll do insert line again, and in this case I'll go very carefully with a parallel ray of light, ray parallel to the principal axis, and it's going to hit the lens at that point. Okay, and I will put a I'll put a arrowhead on there to show direction again. Now that ray of light, you hopefully have worked out where it's going to go. Have a think. Now I hope you said that because we saw it before, the ray of light that's parallel to the principal axis will go through the focal point. The image won't occur at the focal point, but the ray of light that's hitting the lens parallel to the principal axis will carry on and it will go through the focal point. So that's what I'm going to draw now. So shape line. And I'll draw that line going through the focal point carefully there. Now what I've done is I have managed to locate where the image is going to be. So if well, first of all, I will put a arrowhead on there. I didn't do a great job in this diagram of joining those lines together. I hope you do better in your diagram, because it will make a difference to where the image actually occurs. And I can draw the image on this side. It's going to be, you use a ruler obviously, it's going to be there. Okay, so what can I say about this image compared to the object? Well, first of all, the rays of light are joining together, they're converging, so I have a real image, an image that I can put onto a screen. I can also see that this arrow compared to this arrow is upside down. So my image is upside down. I would say my image is inverted, upside down. I can measure the distance of the object and the image, by the way, but I can see here as well, either from that distance compared to that distance, or the image height compared to the object height, I can see that that image is magnified. The image is bigger than the object. I could also ask you to calculate M. We could actually get a ruler and measure image size and object size and get a value of magnification. I won't do that in this case. Okay. Now I hope that made sense. I will talk about it a bit more in the classroom, but when you draw your diagrams, more carefully than me please, and I want you to be able to actually take measurements from your diagram. Okay, so that's the first diagram I'd like to do in your notebook. The next ones I'm not going to do for you, I'm going to ask you to do it yourself. Okay, so the first diagram I'd like you to do is with an object at 2f. So I said that my f was 5 centimeters. I'm going to put my object actually at 10 centimeters. Make sure in your diagram you've got your principal axis, your line down the center of the lens, and you've put little marks where you've got f, f, 2f, and you can put 2f on the other side as well. Alright, so what you might want to do now is to just pause this video and try that diagram. When you've done it, unpause, and I'll give you a second one. Okay, here's the next one I'd like you to try. This might be a tricky one actually. I want you to do a diagram, a lens diagram, with an object at the focal point, at f. See what happens and see what it says about the implications of the image if your object is directly at f. Okay, so please try that. Pause the video if you like. When you're ready, unpause and I'll give you another one. Okay, question 3, and the final one I'd like you to try. I'd like you to do a lens diagram with the object closer than f. So in my case, closer than 5 centimeters. This is the final question. Notice, by the way, I've left a lot of space on the top left of this diagram. That might give you an idea of where the image might end up. So try it please and see what you get. Okay, so when you finish that, that's the final question. Thanks for your attention. It's quite a long one, this one. Try those diagrams, put them up on the Google Classroom for me, and we'll go through the answers in the classroom. And I'll also make a second video where I will do the same as I did with the first question and show you the answers to all of them. Okay, take care everybody, and as usual, as I always say, take care of yourself and your family. I'll speak to you in the classroom this week. Okay, bye-bye.